So students, let me explain to you how we perform filtering of long data sequence using overlap add and overlap save method. So using overlap add method, let me take an example and illustrate to you. Say for example, take two sequences. A filter has an impulse response, say h of n equal to this, and an x of n having a sufficiently long data sequence. So what we can do is consider the length of h of n as m is equal to 3. Since the length is 3, there are 3 samples. The length of impulse response is 3, so m is equal to 3. And we need to segment this input sequence because it's sufficiently long into different segments. So how long a sequence do I take at a time? How do I decide that? Let me consider that value of the segment length as capital L. So I need to split into L segments the entire x of n. Sometimes, in the next L, say here 6 values are taken, the next 6 values are taken, and maybe if just one value is left out, you can leave it. Or if 2 or more sequences are left out, still in the next iteration you append that many zeros so that the length L is made, and the extra zeros anyway you're going to append here, and then you perform your filtering operation. Basically your filtering operation is nothing but linear convolution. So this sequence, to verify your answers in case of this filtering long data sequence method, filtering of long data sequences, you can perform linear convolution of the two given lengthy sequence with your h of n, and then verify the answer that you have got with the method overlap add or overlap save. So in case of overlap add method, the first step is you take the value or the transform length capital N. That means how many point, if you are doing using DFT, IDFT, how many point DFT or IDFT you need to calculate, or how many point circular convolution you need to calculate. That is got by capital N is equal to 2 power m. This is an empirical thing that we consider. Okay, always it's better to take as powers of 2, so that when you say practically implement this, you can use the radix 2 FFT algorithms. That is, if it is in powers of 2, you can use your FFT algorithms. That is the reason we go with a standard method of choosing the total length of your transform at a time to be this. So if you substitute here 2 power 3, m is equal to 3, the length of h of n is 3, so 2 power 3 is 8. So at a time the transform length that you are going to consider is 8. So substitute here, the total length of a convolved sequence at a time, okay, is given by length of that sequence, length of the two sequences minus 1. So that is L plus m minus 1 is equal to n, So when you do that, you get the value of L, already know the value of n. So you get the value of L, that is how many values of x of n I need to segment or take at a time. So I take 6 values, L is equal to 6. So pick the first 6 values, write it down. The rest of this, in order to make the length of both your x of n and h of n at a time equal, since this has got 6 values, I need to append 2 more zeros to make the length equal to 8. That is, if it is x of n, I will append m minus 1 zeros, and for h of n it is 3 values are present. To make the length equal to 8, I need to append 5 zeros. So for h of n, I need to append L minus 1 zeros. Length of x of or x1 dash of n is L, and I append m minus 1 zeros, so that the total length is L plus m minus 1, which is equal to n, which is equal to 8 in this case. And similarly, for h dash of n, I append L minus 1 zeros to make the length equal to 8. Okay, this you got. I hope all of you have got it. So after this, now we perform the circular convolution of these two sequences, or if it is mentioned in the question that perform the filtering of long data sequence using DFT IDFT method, then you will have to perform it this way. That is, find out x1 dash of k, h1 dash of k, multiply these two, okay, multiply these values, you will get this, okay. you'll get your value. And how do I get it? How do I write x1 dash of kx? Just substitute in your your DFT equation. Since it's 8.027 x1 dash of n w8 power nk, you can look at the sequence and write directly. So the sequence, see here, the sequence is 1 2 0 and so on. So this would be 1 plus 2 w8 power k plus 0 minus 3 w8 power 3k, 4 w8 power 4k, 2 w8 power 5k. The 0 terms you can ignore because x of 0 value, x of 0, 1, 2, 3, 4, 5, 6, 7, 8. So 7 and x of 8 values you can ignore. Okay, even the 0 value you can ignore. So respectively, you substitute in this equation. Okay, expanded equation substitute. You can directly see the index value. This is at n equal to 0, n equal to 1, n equal to 2. So n equal to 0 is x of 0, w8 power 0 plus x of 1 is 2, w8 power 1k plus 0 into w8 power 2k. So the w8 power 2k term is not there. You can see here. Okay, w8 power 2k term is not there. 3k term is there. 4k, 5k, 6k. 6k and 7k you don't have. Similarly, how can you write your h dash of k? It is 1 plus w8 power k plus w8 power 2k. You can directly look at the sequence and write your x of k and h of k. Multiply your x1 dash of k, h1 dash of k. When I say x of k, h of k, it's in general. Since we are finding the first segment, it's x1 dash of k, h1 dash of k. Multiply these. Now how to do the multiplication? 1 into all these values. Okay, you get the first row. So like powers, you write it one below the other. So when I multiply w8 power k into this, I get w8 power k. Then w8 power k into 2 w8 power k is 2 into w8 power 2k. I write it below 2k. 2k terms, since I don't have, I write it here. Okay. Then I have w8 power k into 3k. I'll get a 4k term. So write it below the previous 4k term. So whatever like powers are there, I will add all the like powers. See, 3k term, 3k term, 2k terms I'll add together. w8 power k terms I'll add together, add or subtract whatever, and then I am going to get this. Okay, so I know by definition DFT of delta of n minus n naught is wn power k into n naught. So this is of this form. This is the DFT. w8 power k into n naught is 1 here, here n naught is 2, n naught is 3, and so on. So this is your DFT answer. So directly I can write it in this form. If I have 3 w8 power k, I'll write it as 3 delta of n minus 1. If I have 3 w8 power 2k, I'll write it as 3 delta of n minus 2. Okay, I have shared this document, the same problem, in the Google Classroom module 1. So you can take this particular page and you can watch the video simultaneously and solve it. You will understand. Okay, similarly, this is minus w8 power 3k. So it is minus delta of n minus n naught is 3. So write that 3. Next is plus w8 power 4k. So it is delta of n minus n naught is 4. Write 4. Plus 3 w8 power 5k. So 3 into delta of n minus 5. Okay. So if you have this, it means this is at the first position. This is at n equal to 1 you have 3. At n equal to 2 you have 3. N equal to 3 you have minus 1. This is the meaning of this equation. So look at the delta equation and write down the samples. In short, you can just see this and write down the samples directly. Write down the values preceding the w8 term. Directly you write it looking into the power. Suppose there was a 0th term and see the power. 1k means it is the first, n equal to 1 position. 2k refers to n equal to 2 position and so on. So this you got the first convolved sequence, first filtered sequence. Now take the next. That means here you're going to take the next 6 samples. Okay, 1, 2, 3, 4, 5, 6. So what happens is minus 3 is left out. You can stop your filtering till here, or you can take minus 3 and you can append 7 more zeros and you can continue the process. Okay, only difference is if you stop here, maybe 1 or 2 samples than the linear convolved answer, you will miss, that's it. But ideally you can even add -3 and followed by 7 zeros and continue the convolution. So again, take that, append the zeros, make the length equal to 8, perform this multiplication, either using the DFT IDFT method, get your y2 of n. Now you have your y1 of n, y2 of n. See, considering your convolution is done, you need to add the samples. Now how do you perform this addition? That is why it's called overlap add. Consider this is your y1 of n and this was your y2 of n. The last m minus 1 samples of y1 of n, you will add it was the first m minus 1 samples of y2 of n. Add it and you write the answer completely. You will get your final answer. Okay, this is how you do overlap add method. So you can check the answer by performing linear convolution. See, because you left out few values, left out one sample, few samples you will not get in your convolved answer. If you include the last extra sample, append zeros and perform again convolution, say if you take x3 dash of n as 3 0 0 0 7 zeros and h of n and perform convolution, you will get exactly the same answer. Okay, coming to overlap save method, what is the difference? So making the length equal, all that remains the same. M is 3, how much of length you need, lengthy sequence of x of n you need to take at a time, L equal to 6, that's also same. Okay, here the difference is when you take the first 6 samples, because L is 6, you take first 6 samples at a time, and to make the length equal to 8, you append m minus 1 zeros in the starting. H of n remains the same, you add L minus 1 zeros, make both the lengths equal to 8, perform the circular 8-point circular convolution, or if it is DFT IDFT method, write the DFT equation of this, multiply, add all the like powers and get the IDFT, get it in this form, same like before, you get your y1 of n. So here the important step is, here m minus 1 zeros were appended. So always when you get your convolution in overlap save method, y1 of n, discard the first m minus 1 samples. Earlier in overlap add, you would take this entire sample, last m minus 1 values you would add with next y2 of n starting m minus 1 values and you would write everything. Here itself, you discard the first m minus 1 samples and your actual y of n or y1 of n is this. Okay, it will have 1, 2, 3, 4, 5, 6, 7 samples are there. Okay, sorry, 6 samples. Okay, you will have 6 samples. That is equal to the length. So now, similarly, you perform your y2 of n, y1 of n is there. To compute y2 of n, what you should do is, from your x of n, the entire x of n was so much. Initially, you took for x convolving the first 6 samples. You took these 6 samples, right? From the first set of 6 samples, that is from your x1 dash of n, pick the last m minus 1 samples and write it here. Earlier for x1 dash, you appended 2 zeros. So instead of appending 2 zeros, take 2 samples from the previous sample x of n. Okay, and then write down the next 6 samples after that. H of n as usual, appended with L minus 1 zeros, perform 8-point circular convolution, or if mentioned, perform DFT IDFT method, do the multiplication of all this, that is each term here multiply with all this, each term 1, 2, 3 terms, multiply and write everything. Look at the equation and write down your y2 of n. Okay, here again discard the first m minus 1 samples of y2 of n. So you have y1 of n, y2 of n, just append and write it. Final y of n is y1 of n comma y2 of n. you concatenate both y1 and y2 and write it. So that is your actual y of n. This is your actual y of n. So the method is very simple. Hope you have understood.